Welcome to Course of Electromagnetics. Today we will discuss different coordinate system. The first one is rectangular coordinate system, and the second one is cylindrical coordinate system, and third one is a spherical coordinate system. In rectangular coordinate system, the variable is x, y, and z, and in cylindrical coordinate system, the variable is rho. Rho is the radius of cylinder, and phi is azimuthal angle, which is measured from positive x-axis in anti-clockwise directions and z-axis. Z. In the spherical coordinate system, the variable is represented by r, theta, and phi, where r is the radius of sphere, and theta is the angle measured from positive z-axis in clockwise directions, and phi is azimuthal line. Then I will discuss all the coordinate system one by one and how to convert a given point in one coordinate systems to another coordinate systems, how we convert a given vector in from one coordinate systems to another coordinate systems. Then we will also derive the relation between the rectangular coordinate systems to spherical coordinate system or rectangular coordinate systems to cylindrical coordinate system. So in rectangular coordinate systems, the variable is x, y, and z. All the axes, x-axis, y-axis, and z-axis are perpendicular to each other. Suppose a point P is there, and if we are trying to represent point P in rectangular coordinate system or Cartesian coordinate systems, then we have to take projections of this point along xy plane, and the projection of this point is at P dash. If we draw a perpendicular line towards x-axis, this will give you information about y component of this vector, this position vector r, and this will give you information about x component of position vector, and the height or z value is this one. So vector r or position vector r of a point P is given as x I cap plus y j cap plus z k cap, where x, y, and z are x component, y component, and z component of position vector P, and I cap, j cap, and k cap are the unit vector along x-axis, y-axis, and z-axis respectively. So the range of these variables x lies between minus infinity to plus infinity, and y lies between minus infinity to plus infinity, and z values also lies from minus infinity to plus infinity. If we are trying to calculate the differential length in Cartesian coordinate systems, for that purpose this point P, if we increase this differential length by a small increment, this is r, this is dr, then this point we have to take projections of this point P dash to this. Again, this will meet at a point P dash along xy plane, and this will be the small increment along x-axis. We have to take projections along this, and this will be the projections. This represent the x plus delta x, and this represents y plus delta y, and height will be z plus delta z, delta dz or dz, or simply dz. If we are trying to write the differential length in rectangular coordinate systems, then dl in rectangular coordinate system is given by dl is equal to dx ax plus dy ay plus dz az. So differential length in rectangular coordinate system is given by these equations, where ax, ay, and az are unit vector along x, y, and z axis. So if we are trying to calculate the differential area, if we are trying to calculate the differential area in xy plane, since area is vector quantity, area is vector quantity, we have magnitude, and area vector is perpendicular to the plane, perpendicular to the plane. So for that case, we will write differential area which is vector quantity in xy plane, then this is dx dy, and the directions of this area vector is along az, along z axis. Similarly, if you are trying to write the differential area along x z plane, then the differential area is given by dx dz into ay. Ay is area vector. Then differential area in yz plane is equal to dy dz into ax. So in this way we will write the differential length, differential area, and simply if we are trying to write the differential volume is scalar quantity. Differential volume is simply written as dx dy and dz. So differential volume we can write. This differential volume is scalar quantity. The next one is cylindrical coordinate system. Cylindrical coordinate system, the variable is rho, phi, and z. I already told you rho is radius of cylinder, then phi is azimuthal angle, azimuthal angle. So point P is given in, then we have to take once again projections of this point in xy plane. Suppose this point meets the xy plane at point P dash, then we have to join this point with origin, this point with origin. This represents a row vector. This represents row vector. Rho is radius of cylinder. Is radius of cylinder, and and this angle this angle is phi. Phi is azimuthal angle, and this phi is measured from positive x axis in anti-clockwise direction. So we will calculate this azimuthal angle from positive z axis in anti-clockwise direction. The range of this rho, since rho is radius of cylinder, the range of this is lies between 0 to infinity, and phi is azimuthal angle. The minimum value of phi, if this point P lies in x axis, then phi will be 0. So the minimum value of phi will be 0 and maximum value of phi is less than 2 pi, and the value of z lies between minus infinity to plus infinity. If I write a vector in cylindrical coordinate system, if we write a vector in cylindrical coordinate system, then the is vector A is equal to a row component of vector field A plus a phi plus az. If we are trying to calculate the magnitude of this vector, magnitude of this vector is a row square plus a phi square plus az square under root. So in this way we can calculate the magnitude of this vector. So the next is we have to find the relation between rectangular coordinate system and cylindrical coordinate systems. This row vector, this row vector is making phi angle with x axis. So in to simplify this, if we consider this axis, y axis and x axis, and this row vector is making angle phi with x axis. If we take the component of this vector, then the x component of this vector is x is equal to rho cos phi, and y component of this vector is rho sin phi. Since this is making an angle phi, so the component of this row along x-axis is rho cos phi, and component of this row along y-axis is rho sin phi. And if we have idea about rho and phi, then we can with the help of this equation we easily convert a point which is given in cylindrical coordinate systems. We easily convert that point in Cartesian coordinate system or a rectangular coordinate systems. Similarly, if we square equation 1 and square equation 2, and by adding square of both equations we obtained rho square is equal to, we obtained this relations. So rho is equal to x square plus y square under root. If we divide both the equations second upon first, then we obtain tan phi is equal to y by x, or phi is equal to tan inverse y by x, and z is equal to z. If a point is given in rectangular coordinate systems, that means the x value, y value and z value of that point is given, and we are trying to convert this point in cylindrical coordinate system. Then we have to calculate rho and phi. So phi is calculated with the help of these equations. Phi is equal to tan inverse y by x, and rho is calculated with the help of these equations. Rho is equal to x square plus y square under root. With the help of these two equations, we easily calculate or convert one point which is given in rectangular coordinate system. We easily convert that point in cylindrical coordinate system and vice versa. Thank you.